Hi, we are from Group 7 and we will present about Topic 7, which is ballistic load on concrete structure. Before that, I will introduce myself. I'm Celestia Sakai and this is my group members. Muhammad Aiman bin Muhammad Nasir, Muhammad Azim bin Jamel, Muhammad Iqmal bin Badaruddin, and Nabila Shuhada bin Design. I will present about introduction. Ballistics. Ballistic is the field of mechanics concerned with the launching, flight behavior, and impact effects of projectiles, especially ranged weapon munitions such as bullets, unguided bombs, rockets, or the science of art of designing and accelerating projectiles so as to achieve a desired performance. Second, a ballistic body is a free-moving body with momentum which can be subject to forces such as the forces exerted by pressurized gases from a gun barrel or a propelling nozzle, normal force by lifting, and gravity and air drag during flight. There are basically three types of ballistic, which is internal, external, and terminal ballistic.
My name is Nabila Shuhada binti Zain. I will present about alternative research, the type of ballistic loads. First, internal ballistic load, the study of what happened within the barrel of a weapon from the moment the firing pin hits the primer to the time the bullet exits from the barrel. It is mainly concerned with propellant pressure acceleration of the missile with it is in the bore, muzzle, velocity, and recoil. 5 general equations used in interior ballistic. First, the equation of state of the propellant. Second, the equation of energy. Third, the equation of motion. Fourth, the burning rate equation. Fifth, the equation of the form function. External ballistic load. External ballistic or exterior ballistic is the part of ballistics that deals with the behavior of a projectile in flight. The projectile may be powered or unpowered, guided or unguided, spin or fin stabilized, flying through an atmosphere or in the vacuum of space, but most certainly flying under the influence of a gravitational field factor, wind, vertical angle, ambient air density. Terminal ballistic load. Terminal ballistic, also known as wound ballistic. A subfield of ballistics is the study of the behavior and effect of a projectile when it hits and transfer its energy to a target. Bullet design and the velocity of impact largely determine the effectiveness of its impact. Can be applied to any projectile striking any target. Much of the topic concerns the effect of small arm fire striking leave target and their ability to either incapacitate or kill them. Common factors include bullet weight, composition, velocity, and shape.
Okay, impact ballistic load on the concrete slab. Commonly, the impact ballistic load is classified into the two categories. First one is hard impact and the second one is soft impact. The hard impact is the example is missile do not have the sustainable deformation compared to the impact structure. Soft impact, the missile deforms sustainably as well. So, the structure subject to impact load can also be grouped according to the response. Structure that suffer only local damage around the point of impact, and structure that respond to impact through global member deformation and combine of both these two response. Local damage are categorized in three levels. A. Penetration of the missile and spalling of the pieces from the penetration phase. B. Significant scraping from the both of front and back face of structure. And C. Profession of the element.
My name is Muhammad Azim bin Jamil. My metric number is CF190193. And now I want to present about the common type of cracks or failure pattern on concrete. First, plastic shrinkage concrete cracks. When the concrete is still in plastic state, it is before hardening, it's full of water. When the water eventually leaves the slab, it leaves behind large void between the solid particle. This empty space makes the concrete weaker and more prone to cracking. Second, expansion concrete cracks. Heat causes concrete to expand. When the concrete expands, it pushes against anything in its way. It is a brick wall or a junction slab, for example. When neither has the ability to flex, the expanding force can be enough to cause concrete to crack. Third, having concrete cracks. When the ground freezes, it can sometimes lift many inches before thawing and settling back down. This ground movement brought on by the freezing and thawing cycle is a hard factor contributing to concrete cracking. If the slab is not free to move with the ground, the slab will crack. Fourth, settling concrete cracks. Ground settling below a concrete slab can also cause cracking. Settling cracks typically occur in situations where a void is created in the ground below the concrete surface. Fifth, concrete cracks because by overloading the slab. Placing excessive amount of weight on top of a concrete slab can causing cracking. When it comes to residential concrete slabs, overload of the actual slab is not all that common. Instead, what is more likely to occur is excess overload on the ground below the slab. And lastly, concrete crack caused by premature drying. There are two common types of crack brought on by premature drying. First, grazing cracks are very fine surface cracks that resemble spider webs or shattered glass. When the top of a concrete slab loses moisture too quickly, grazing cracks will be likely appear. While unsightly, grazing cracks are not a structural concern. Second, crusting cracks typically happen during the concrete stamping process, which is a way of adding texture or pattern to concrete surface. On sunny or windy days, where the top of the slab dries out quicker than the bottom, the top of the concrete surface can become crusty. When the stamp abandoned, it pulls the surface apart near the stamp joint and causes small crack around the outside edge of the stone.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqmal bin Darudin. So I will presenting the recommendation. So in recommendation, strength is quality which all materials are referred to. They are known as either strong or weak. Concrete can be very strong when compression shape stress absorption is involved. The concrete known as reinforced concrete is attached with rebar. Rebar is very good for taking tensile stress, and this is why reinforced concrete is used for making it. The application of rebar to concrete makes its protection more detailed. So, in my recommendation, or in our group recommendation, using concrete slab with rebar is more strong rather than concrete without rebar in construction. That's all.